So today we're starting a new unit called logarithms. And at the very top of your page it says a logarithm is just another way to write an exponent. And that's going to be something that I'm going to be saying over and over and over today. I'm going to shoot for 50 times. But here's the thing. We're given the exponential form, which we are very familiar with the exponential form. And what we're going to do is we're going to convert it to a logarithm. And again, a logarithm is just another way of writing an exponent. So, in this particular case, when we take 3 squared equals 9 from the exponential form, the exponent is what the logarithm equals. So, in this 3 squared equals 9, our exponent is 2. It's going to go in that spot. And what we did is we used some logical arithmetic. We said 3 squared equals 9. And this 3 drops down half of a space. It's a subscript. So it's base, and then the number, 9 is the number, and then squared. The exponent is what the logarithm equals. If we try another one here, 4. This is 4 to the 3rd power. In the exponential, we start with 4. In our logarithm, we start with the 4. Again, it's a subscript. It drops down half a space. A logarithm is another way of writing an exponent. So what our exponent is in this problem is 3, and that's what our logarithm is going to equal, which only leaves the 64. That's our last part. There's 3 pieces to the logarithm. The 4 in this case is the base. I call 64 the number, and the 3 is the exponent. So if we look at one without boxes here, we're still going to start with that word log, which is the abbreviation for logarithm. Our base is 2, so drop your 2 down half a space. A logarithm is another way of writing an exponent. So what our exponent is what we're going to set our logarithm equal to, which means that the 128 is our number. In terms of reading these logarithms, and I do have this in the notes momentarily, but our first one, this is log base 3 of 9 equals 2. And the second one is log base 4 of 64 equals 3. And the third one is log base 2 of 128 equals 7. So as we flip the page here, or at least flip my page here, again, a logarithm, abbreviated log, is simply another way of writing an exponent. So if we take this, it says this form, the logarithmic form, is read as log base b of a equals x. That's the logarithmic form. And then when we look at the exponential form, it would be b to the x equals a. And that's what we're going to do today on our notes and practice. We are going to write an exponential and logarithmic form. We're going to write a logarithmic form into exponential form. Again, a logarithm is just another way of writing an exponent. So don't get caught up in that word logarithm. It's just another way of writing an exponent. One other piece to be aware of is if we have simply log A equals B, in other words, we don't have any number written as our base right there, is understood to be a 10, on your calculator, regardless of the kind of calculator you have, the base on that calculator is base 10. So again, no base written, it's base 10. First one, we're going to write each exponential equation in logarithmic form, just like we were doing above. We just don't have the boxes, but we can start with log base 2. Logarithm is another way of writing an exponent. So our exponent is 6. That's what we're going to equal. And then we have 64. Number 2. 4 to the negative 2 equals 1/16. Converts to log base 4. Again, drop that 4 down a half a space. The exponent, in this case, is negative 2, which makes our number 1/16. Log base 4 of 1/16 equals negative 2. Number 3, 1/3 to the 3 equals 1/27. Log of 1/3. Again, the 1/3 drops down half a space. It is the base of our logarithm. The exponent is what this problem equals, which is 3. And then we're going to put 1/27 here. Log base 1/3 of 1/27 equals 3. Number 4. 3 to the 7th equals 2,187. Log base 3. The exponent is what the logarithm equals. So our exponent in this problem is 7. So our logarithm equals 7. And 2187 goes in the third spot of our logarithm. Log base 3 of 2187 equals 7. Number 5, 12 squared equals 144. Converts. Log base 12. A logarithm is another way of writing an exponent. So the exponent in this problem is 2. That's what we're going to set this equal to. And finally, on converting exponentials to logarithms, one last time. Log base 5 of 125 equals 3. A logarithm is another way of writing an exponent. Our exponent in this problem is 3, so we need to set this equal to 3. Now, to finish here, we are going to convert logarithms back to exponentials. And I use a system called the curly Q. Very mathematical term, by the way. But here's the curly Q in this. I circle the base in this problem, in this case 7, and we circle around. So it looks like that. So our base is 7. Again, a logarithm is another way of writing an exponent. Our exponent is 2, and this equals 49. And the nice thing about this problem is, if I've done my math correctly, this should be a true statement. So rhetorically, does 7 squared equal 49? Yes. When we look at number 8, again, we start with the base. There's our base of 2. And we're going to curly Q around. So this is going to be 2 to the negative 4. Again, a logarithm equals an exponent, and we just wrote the negative 4 in the exponent position. Seems logical. And then we equal 1/16. Number 9. start with the 8. We're going to curly Q around. This is 8 to the x equals 48. Again, our only goal today is to be able to convert a logarithm into exponential form and exponential into logarithmic form. Now, we don't have a mental check on this one because we don't know what x is, but the one part that we do know about x is that x should be an exponent, and when we converted it to an exponential, it's definitely an exponent. On problem number 10, by the way, the base of 10 did not need to be written, but it is in this case. It could be written. It doesn't have to be written. If we curly Q around, this turns into exponentially 10 to the 5th equals 100,000. Again, a logarithm is another way of writing an exponent. Whatever the logarithm equals is the exponent. Number 11, curly Q. Start with the 4. And we're going to get 4 to the 5th equals 1,024. And to finish, curly Q around. And what we end up with, we start with the 9, curly Q around, 9 to the 3 equals 729.